Hello everyone, my name is Tyler Alvarez and today I'll be presenting experiment number 7, chemical reactions. Introduction. By definition, a chemical reaction is a process that involves rearrangement of the molecular or ionic structure of a substance, as opposed to a change in physical form or a nuclear reaction. This experiment is split into two parts. In the first part, reactivity to metals, we explore chemical reactions with compounds that are least and most reactive to metals, specifically aluminum in the form of foil. In the second part, reactivity in solution, we explore chemical reactions with a variety of compounds and observe the wide range of outcomes within chemical reactions. For materials, there's a mixture of student supplied and science interactive supplied. For student supply, we need aluminum foil, bottle of distilled water, box of toothpicks, dish soap, drinking glass, pair of scissors, roll of paper towels, roll of toilet paper, set of measuring spoons, sheet of white paper, source of tap water, and salt. For science interactive supplied, we need experiment bag chemical reactions, which has a plethora of compounds that we will be using for chemical reactions, an IKI indicator, pair of gloves, pair of safety goggles, permanent marker, ruler, short stem pipette, test tube cleaning brush, and a well plate for 24. And now onto the procedures. In experiment number 6, chemical reactions and equations, there are two parts. Part 1 is reactivity of metals and part 2 is reactions in solution. As always, before starting, make sure you put on your protective gear. For part 1, to commence, you're going to need a ruler and scissors to cut a 2 by 10 strip of aluminum foil. Once you have your aluminum foil, place it flat on a countertop and place 2 layers of bathroom tissue on the top of the foil. Grab a cup. Measure 1/4 of a teaspoon of table salt and pour it in the cup. Next, measure 1 tablespoon of distilled water and also pour it in the cup. With those components, you're now going to mix. Once you're done mixing, measure and pour 1 tablespoon of vinegar onto the bathroom tissue, making sure that the aluminum foil is damp. Let the vinegar sit for 5 minutes. Once those 5 minutes are up, remove the toilet tissue from the foil and discard it. Rinse the aluminum foil with tap water and once again place it on a smooth surface. Using a paper towel, gently blot away the remains on the foil. The goal is to make sure that the aluminum foil is dry. Once you made sure that the aluminum foil is dry on both sides, gently press against the aluminum foil to remove any wrinkles or creases. With the salt mixture that we created in the cup, saturate a paper towel and press it against the aluminum foil until it's damp. With a permanent marker, separate 4 different compounds on the aluminum foil. Those compounds are AgNO3, CuSO4, CaCl2, PbNO3, 2. Starting with AgNO3, grab the pipette, cut the tip, and place 2 drops of AgNO3 into its designated spot on the aluminum foil. Upon contact with the aluminum foil, make immediate observations and record them. It is also important to record the time that the chemical reaction started. Once you recorded your initial observations, let the AgNO3 sit on the aluminum foil for 5 minutes. Once 5 minutes are up, record your observations once again. Observations will be recorded for both the compound, aka the chemical reaction, and the aluminum foil. Now that the initial and 5-minute reaction has been recorded, allow the reaction to continue for an additional 3 hours. Once the 3 hours are up, record your observations for the chemical reaction. Rinse the aluminum foil with tap water to remove any residue from the solution. Then, record your observations of the aluminum foil. This procedure will be repeated for the other 3 compounds. And that concludes part 1. Now, let's transition into part 2. To start, place a white sheet of paper on the table. Grab the 24 well plates and set it on top of the paper. Compounds in the form of pipettes are going to be used to create chemical reactions. With scissors, carefully snip off the tips of the pipettes. In this part of the experiment, lots of observations are going to be made about the chemical reactions occurring. The pipettes have labels that will guide you by letting you know what to use for a chemical reaction. The chart provided gives us the information on what chemicals to mix. 2 different compounds will be mixed for each chemical reaction. For each compound poured, about 3 to 4 drops is sufficient to cause the chemical reaction. Once the 2 compounds have been poured in to cause the chemical reaction, make sure to use a toothpick to stir. 4 different things will be recorded in part 2 of this experiment. Considering that we are working with 2 different compounds for each chemical reaction, we will be recording each compound's initial state. Once the chemical reaction has occurred, we will be recording what we observe. And finally, we will be determining whether the chemical reaction was a chemical change. All of these components will be recorded for each chemical reaction. There is a total of 14 reactions that will be recorded in this part of the experiment. And that concludes the procedures. As shown on screen, here are my results for Part 1, Reactivity of Metals. This includes start time, initial appearance of chemical, initial appearance of foil, observations after 5 minutes, observations after 3 hours, and appearance of foil after rinsing. Next are my results for Part 2, Reactivity in Solution. This includes all of the 14 chemical reactions that we were required to observe and record. Next is the discussion. Part 1 discussion. CaCl2 had almost no reaction for the initial 5-minute and 3-hour observation. The chemical reaction with the most change was AgNO3. The droplet was first clear with white spots and transitioned into a muddy bubble. CuSO4 changed color from the initial observation and went from blue into a dark brown streak. PbNO3 had minuscule change. Part 2 discussion. There was a plethora of chemical reactions in this part. Each demonstrated a different type of change. There was change from color, clearness, lightness, etc. There was a mixture of expected changes to spontaneous reactions. Finally, the conclusion. There is a variety of chemical reactions. These chemical reactions are important because they allow us to discover new resources and tools that can help us progress and prosper as a society. Chemical reactions help us further understand how life has come about. No matter the compound, chemical reactions will always be useful. Thanks for watching.